Good morning, everybody. So as I mentioned yesterday, or 2 days ago, we're doing things a bit out of order today. I'm going to cover section 5 first, then we'll go back and do section 4. So this section is on the binomial theorem, right? And you'll find that it's like this super cool thing, this binomial theorem. All right. So let's first talk about what a binomial is. If you remember, a binomial is an expression that involves the sum of two unlike terms, right? So for example, x plus 3 is a binomial, a minus b is a binomial, and so on, all right? Now, we know what happens when we have, for example, x plus 3 squared, right? Or a minus b squared. You know that there is a special pattern here, right? Let's just recall that pattern. What is it? It's this one squared, and then minus 2ab, and then this one squared, okay? And we kind of just leave it there. But you'll find in this lesson that this pattern, or a similar pattern to this, exists no matter what this exponent is, right? So anytime you have a binomial raised to an exponent, there is a cute little pattern just like this one. And today we're going to unlock that pattern, and this is so exciting for me. Okay, so let's go. Okay. When we do go from this a minus b squared to this form, we call this the expansion of a minus b squared, okay? So if it's a minus b cubed and we multiply it out and write out all the terms, that's the expansion of it, okay? All right, so let's do the pattern for a little bit, and let's see if we can figure out what's happening here. All right, so first, if you have a binomial a plus b, and if you have it raised to the smallest possible exponent, 0, well then, what is that? That's just 1 times a to the 0, b to the 0, okay? Which means it's just a 1. Now, if you have a plus b to the 1, right, what is that? That's just a plus b. So look at what you have here. This is a more intricate way of writing the same thing. But if you look closely, it's 1a times nothing plus 1b, right? So it's really just a plus b as you would have expected. Now, if we move on to a plus b squared, this is the one that we know, it's 1a squared, b to the 0 is 1, plus 2ab plus b squared. It's exactly what we wrote up here. And similarly, if we do a plus b cubed to the 4th to the 5th, this is what we get, okay? Now, there are a couple of very important things that happen here. First and foremost, we're going to define this exponent as n, right? So n is going to be that exponent. All right, and now let's first figure out how many terms there are at each step. When n is 0, you have one term. When n is 1, there are two terms. 1 plus another one. When n is 2, there are 1, 2, 3 terms. So you can see here that each expansion has n plus 1 terms, one more term than the exponent. Okay, here's another pattern. The first term and the last term of each expansion is a to the exponent here and b to the exponent. All right, so let's look at this last one. This last row, the first term is a to the 5, a to the 5. The last one is b to the 5, b to the 5, okay? Next, this is my favorite one. The sum of the exponents for each term is n. Okay, so take a look at this one. Pick any random term. I'm going to pick, this one. Exponent of 3, exponent of 1. There's 3 plus 1 is 4. Look at this one. It's a plus b to the 4. Okay, that was luck. Let's just pick another one. This one. Exponent of 2, exponent of 3. 2 plus 3 is 5. Oh my God, exponent of 5. All right, let's look at this one. Same row. exponent of 4, exponent of 1. Oh my God, it's a 5. So with each expansion, the exponents in each term add up to n. Okay, now, I said that was my favorite one, but you know what? I was wrong. This is my favorite one. Okay, take a look at the exponents of the a's and then the exponents of the b's. So I'm going to take this row. Look at what's n? N is 3. Okay, so look at the exponent of a, 3, 2, 1, 0. So it starts from this number and goes to 0. Oh, and now look at the exponents of b. 0, 1, 2, 3. Oh, reverse order, starts from 0 and goes to 3, right? So the powers of a decrease from n, and the powers of b increase to n. Okay, fabulous. Okay, now for the biggie, the coefficients, these numbers. You see a pattern? They're all ones. Do you see a pattern here? They're all ones. Well, what about all these other random numbers, the 2 and the 3 and the 3 and the 4 and the 6 and the 4? Oh my God, symmetry. Look at this one. 3, 3. It's symmetric if you split it this way. Oh my God, look at this one. There is a 6 and then a 4 and a 4. Oh my God, look at this one. If I split it halfway, 10, 5, 10, 5. Oh my gosh, so many things to talk about. Okay, let's talk about those coefficients first of all. Okay, Pascal's triangle. All right, so these coefficients that I talked about, the last thing that I talked about, are called binomial coefficients. All right, and they could be arranged in triangular form as you see here. Okay, now the way this works is this. The starting point, you have a 1, 1, 1. Then the next row, you have a 1 in the beginning and a 1 at the very end. And then each number inside, so to get this number, it's the sum of the two numbers that's above it. Okay, so let's do another one here. You have a 1 to start, a 1 to end with. Then this number is the sum of 2 plus 1, 3. This number is the sum of 1 plus 2, 3. Okay, let's skip to this row. You have a 1 in the beginning and you have a 1 in the end. Then the next number is the sum of 4 plus 1. The next number is the sum of 6 plus 4, and so on. Okay, now we'll do a little bit more with this, but let's try to generate a brand new one of ourselves. So 1, 1, 1. Then I have 1, add these two up, 2, 1. Then 1, now I need a new number in between here, so 3. I need another number in between here, so 3. And then you end with a 1. Okay, 1. This gives you 4, 6, 4, 1. And again, 1, 5, 10, 10, 5, 1. Okay, so that's how you generate that. Okay, let's talk about levels. This first level is n equals 0. So this is equivalent to a plus b to the power of 0. The second level is n equals 1. This is equivalent to a plus b to the 1. So you have to remember that you start with 0. Next, n equals 2. So this is equivalent to a plus b to the 2, right? And so recall, what's a plus b squared? It's a squared plus 2ab plus b squared. Look, the coefficients are 1, 2, 1. 1, 2, 1. Okay, so that's how we generate this. Okay, so this way you could figure out the coefficients of any binomial expansion. All right, so you know what? Let's just do 1. All right, so we're going to expand 3x plus 2 to the power of 5. Okay, so if the exponent here is 5, I have n equals 5. So I need to generate a triangle. So that's n equals 0, 1, n equals 2, n equals 3, and then here, this one is n equals 5. Okay, so that's the one I'm going to use. All right, so here's how we do it. Now, in this expansion, in this binomial, this is A, and this is B. All right, so what I do is this. I get my first coefficient, that's a 1, times A to the power of 5, right? Because my exponent is 5. And then B to the power of 0. Okay, plus the next coefficient is 5. Then I have A to the power of 4, B to the power of 1. So all the red exponents are going to decrease and all the blue exponents are going to increase. At each step, my total exponent is going to be a 5. Okay, the next coefficient is 10. 3x to the 3, 2 to the 2. My next coefficient is another 10. 3x to the 4. I'm sorry, 3x to the 3, to the 2. 2 to the 3, right? Again, 2 plus 3 adds to 5. The next coefficient is 5. 3x to the 1, 2 to the 4, and then finally the next coefficient is 1. Okay, and here I have 3x to the 0, 2 to the 5. Again, in each term, the exponent is 5. Now, you have to go in and you have to actually multiply all these numbers out. So here I have 3 to the 5, which is 243, x to the 5, plus 5 times 3 to the 4 is 81, times 2, times x to the 4, plus 10 times 27 times 4 times x cubed, plus 10 times 9 times 8 x squared, plus here I have 5 times 3 times 16 times x, plus 2 to the 5 is 32. Now, obviously, you can combine steps here, right? I'm just doing it, ad nauseum the first time. And then we're going to have to go a little bit faster. So finally, when all is said and done, this is 243x to the 5 plus 810 x to the 4 plus 1080 x cubed plus 720 x squared plus 240 x plus 32. And there you have it. That's the expansion. Okay. All right. So let's do this one. This next one, we're going to do it a little bit quicker now. Okay, so this is A and this is B. Now, what's important is your B in this case is negative 2y, right? Because the expansion is for A plus B. So if there is a negative, you have to take the negative along, right? So watch how I do this. Now this is the 6th term. If it's n equals 6, then in my Pascal's triangle I have to go another step. So it's 1, 6, 15, 20, 15, 6, and 1. Okay, so this is for n equals 6. All right, so those are going to be my coefficients. So what I also like to do sometimes is, just put my coefficients. So 1, and then I have a 6, and then I have a 15, and then I have a 20, and then I have another 15, and then I have a 6, and then I have a 1. Okay, you can do it that way, or you could put it in later on. It's up to you. All right, so let's go ahead and do this. So I have x to the 6, negative 2y to the 0, x to the 5, negative 2y to the 1, x to the 4, negative 2y squared, right? Each time the exponents have to add to 6. X cubed, negative 2y cubed, x squared, negative 2y to the power of 4, x, negative 2y to the power of 5, and then here I have x to the 0, negative 2y to the 6, okay? We multiply them all out, we do all the math, and then in the very end I have x to the 6 minus 12x to the 5y plus 60x to the 4y squared minus 160x cubed y cubed plus 240 x squared y to the 4 minus 192 xy to the 5th plus 64 y to the 6. Okay, what do you notice here? This had an x minus 2y, right? There was a minus in the middle here. And what happened to the signs here? Look, you have positive, negative, positive, negative, positive, negative, right? So if there is a negative here, the signs will alternate. Okay, so if you get really quick at it, if there is a negative, you could just ignore the negative at first, just alternate sign in the end. Okay, but be careful. Don't do that until you're very, very sure of what you're doing. All right, now this was just binomial expansion. The binomial theorem is this. Okay, let's talk about this. All right, so if I were to ask you what this is, right, what would you tell me? So this is not just like, okay, so I'm not just excited about a 3 here, right? This is not just like 3 exclamation mark. No. So if you remember, this is 3 factorial. And when you have 3 factorial, you multiply all the numbers from that number down to 1. So 3 times 2 times 1. So that equals 6. Okay? And one thing you need to remember, and I'll go over it one time when I'm with you guys, is 0 factorial is always 1. Okay? So 0 factorial is always 1. Okay, now, the binomial theorem says this. So if you go up here for a minute, back to the first example we did, look at these exponents. So look at this one, that's n, right? Now, we have another counter, it's a variable, r. And what r does is r goes from 0 to n. So for example, whichever term you're on, that's r. So this is the 0th term, r is 0. This is the first term, r is 1. This is the second term, r is 2, and so on and so forth. So if we have it that way, if that is always r, okay, then how do we define this term? This term is always n minus r, right? If r is 1 here and n is 5, then this is n minus r. If r is 2 here, then this is n minus r, and so on and so forth. Okay, so that's another way we could label our exponents. So now that's what this says here. If each term looks like this, a to the power of n minus r, b to the r, then the coefficients are given by this formula. So to generate any of the coefficients, this is the formula you use. n factorial over n minus r factorial, r factorial, all right? Okay, when is this good to use? Okay, so suppose you are given something like this, x plus y to the power of 57, and you want to know the coefficient of the 36th term. Okay, you're not going to do Pascal's triangle for 57 steps, as fun as that is. This process gives you that term directly. Okay, so that's when it's used. Let's just try our hand with the expansion here using this formula. Okay, now the notation for it is this, and this is a combination. It's called combinations. You learn it in a different part of mathematics where you learn about statistics and probability, but we're just going to apply it now. So be patient and let's just apply that one. Okay, so here's how it works. What we have to do is we have to do a plus b cubed. Okay, so the way it works is this. You have the coefficient here. So you have the first coefficient, and that's c. Okay, look at what it says here, n and then r. So 3, and then this is the 0th term, so it's 0. And then you have a cubed b to the 0, same as before, plus c. This is, so what is this one? This is n, and then you have r. N is always the same, and then r is now 1. It went from 0 to 1. And then we have a to the 2, b to the 1. Okay, plus c, 3, 2. So at each time it's n stays constant, and then the r goes 0, 1, 2, 3. Okay, and then here, so we had a to the 3, a to the 2, a to the 1, b to the 0, b to the 1, b to the 2, plus c to the 3, 3, a to the 0, b cubed. Okay, you stop when these are the same. Okay, all right, so now let's go ahead and expand this. So each one of these means, okay, n, so look at what it says here, n factorial. So you take the first one factorial over the difference factorial, the second one factorial, a cubed b to the 0. Now let's do it again. This one, the first one factorial, the difference 2 factorial, the second one factorial, a squared b to the 1, plus first one, the difference, the second one, a b squared, plus the last one now, first number over the difference, and then the second one factorial, a to the 0, b cubed. Okay, so what do we have here? This, here we have 3 factorial. We just said that that one was 6. Over 3 factorial, that's 6. Over 0 factorial, that's 1. So that's just a 1. Okay, a cubed, b to the 0 is just 1. Plus, here I have 6 over 2 factorial is 2. So that's a 3, a squared b, plus 6 over 2 factorial is 2, so 3, ab squared, plus 3 factorial is 6, over 3 factorial is 6, so that's a 1, b cubed. So finally, that's a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, so I actually switched to this. So this one, this is the reason why I gave you the new packets, is because I hadn't changed the calculator instructions for the TI Inspire. All right, so you could actually do this with your graphing calculator, right? So instead of doing that, that long, drawn out process, now, of course, you have to do it manually. You have to know how to do it manually for me, but you also have to know how to do, all of these with the calculator. All right, it's a lot quicker. So let's just do these with the calculator for now. All right, I'm gonna do this one with the calculator. So here, all right, if you want to find the combination of 3 and 1, right, so C3, 1. So let's go to the calculator. All right, what you're gonna do is you're gonna press menu, and you're gonna go to probability number 5, and you're gonna go to combinations number 3, and it gives you that instruction there. Now here, so look at what I have here. If you want to find 3, 1, you have to enter those numbers. So the first number, comma, the second number, and then press enter. So here, you're going to do the first number. And the comma is all the way at the bottom here, right? All the way on the bottom left-hand side, comma 1, close parentheses, enter, and there you have it. It's 3, okay? And now if you wanted to bring this back and edit, and if you wanted to do 3, 2, then it's 3. And if you wanted to do, let's say, 3, 0, then it's 1, and so on and so forth, okay? So that's how you do it with a calculator. It's a lot quicker, I know. All right, so look at what we're going to do here. So it says to find the coefficient of the indicated term in each expansion. So this is what I was talking about before, right? So I have a minus b to the 10. Okay, so there are 11 terms. And I want to find the coefficient of the 4th term. So it's a lot more difficult to do it using Pascal's triangle and to like expand it that way. With this, the binomial theorem, I could just go to it directly, right? So what is the form of the binomial theorem? It's C n r, okay? A to the power of n minus r, b to the power of r. That's just what the binomial theorem says. Okay, so let's talk about this for a minute, okay? If it's the 4th term, then r, it starts from 0. So 0, 1, 2, 3, r is equal to 3, okay? So the way you do it is you say r is always going to be that number, the 4th, minus 1, right? So just remember you're counting from 0 to that number. So r is 3, no matter how you look at it. And n is equal to 10. So n minus r is equal to 7. Okay, so here let's just plug all that in. So C, n we said was 10, r we said was 3. And now a is the first term, right? So you have a to the power of n minus r, we said that was 7. B, that's the second term, so negative b to the power of r. All right, and now that I'm going to put in my calculator. So let's go here. I'm going to go here, bring it back to edit. So I have now 10, comma 3, 120. Okay, fabulous. So that's 120. A to the 7, negative b cubed. All right, so that's negative 120. A to the 7, b cubed. Okay, now this entire thing is the 4th term. But the coefficient, which is what this is asking me for, is negative 120. All right. Okay, let's take a look at this one. This is another way of asking you the same thing. Okay, so this one is telling you the x to the 7y term. All right, so look at what these are. This is n minus r, and then there is an exponent of 1 here. That's r. Okay, so in this case, n is equal to 8, r is equal to 1. Okay, you need that in order to be able to write down your binomial coefficient term. So the formula is CNR, a to the power of n minus r, b to the power of r. Okay, now you forget this, all right? You go with what you have in your original binomial. So this is going to be C8, 1. The first term, 3x, to the power of n minus r. And then the second term, negative 4y, to the power of r is 1. Okay, I put this in my calculator, and that gives me an 8. Then I have 3 to the power of 7, so you have to take all of it. It's not just the 8 that you're looking for. You can't take that shortcut. Times negative 4, and then I have x to the 7y. And then when you plug all of these numbers into the calculator, it's negative 69984. That's the coefficient. And so do you see how you did in fact end up with the x 7th y to the first term? Okay, so that's how you do it. All right, now this one is a full-on expansion. So let's go ahead and do it. So again, if I ask you to expand using the binomial theorem, you're not allowed to use Pascal's triangle. You have to do it using the binomial theorem. So let me show you, my quickest way to do it. Okay, so here's how I do it. So it's C, we actually did one before that with the cube term. So it's C, you start with n, and then 0. And now with each term, this is going to stay the same, n is the same, but the 0 is going to go from 0 up to 5. So here I have 2t to the 5, 3u to the 0, plus c5, 1, 2t to the 4, 3u to the 1, c5, 2, 2t cubed, 3u squared, plus c5, 3, 2t to the 2, 3u cubed, oops, this way. Again, so each time I make a mental note that my exponents are adding up to n. And then c5, 4, 2t to the 1, 3u to the 4, and then c5, 5, 2t to the 0, 3u to the 5. Okay? Fabulous. Okay, so now each one of these, you have to do it, you should know how to do by hand and with a calculator. So if you were doing this first one by hand, right, it would be the first number factorial, the subtracted 5 minus 0, and then the second number factorial, okay? And that will be a 1 times 2 to the 5 here is 32, times 1, t to the 5, plus this gives you a 5 times 16 times 3, t to the 4u, 10. So where do I get this 10 from? Let's do this here. This is the first number factorial, 5 minus 2, 3 factorial, 2 factorial, all right? And I'll show you how to put factorials in your calculator as is as well. Okay, so here we are going to do 10 times 2 cubed is 8, 3 squared is 9, t cubed u squared. And then I have another 10 times 4 times 27, t squared u cubed. And then C54 is actually 5 times 2 times 81 tu to the 4. C55 is 1. 2t to the 0 goes away. 3 to the 5 is 243. U to the 5. Finally, I have 32. T to the 5th. 240. T to the 4u. 720. T cubed u. 1080. T square u cubed. 810 tu to the 4. 243 u to the 5. Okay? Okay, I feel like this deserves a happy face. I'm just having too much fun with that. All right, sigma notation, just when you thought it was over, it's back. Okay. Do you see how with each one of these, you're just adding numbers? Finite number of numbers, infinite number of numbers. You're just adding numbers, and there is a pattern to it. What does it remind you of, guys? Oh my God, does it remind you of sections 1 and 2 and 3, like sequences and series? It sure does. There too, we were adding up numbers that had a pattern. So we could easily write this in sigma notation, okay? So since it's just a sum, it could be written in sigma notation. So we don't, mathematically though, the notation is such that you can't use that notation inside a sigma. Instead, however, there is an equivalent notation. Just because we like to spice things up in math, there is an equivalent notation to that, and that is this, okay? So if I was walking down the street, and if I saw a billboard, and on the billboard it said this, I would say, oh, that's the same exact thing as that, okay? All right, in fact, when was it? What day is it today? Well, I'm making this screencast on Thursday. Last Wednesday, in fact, I saw just this on a billboard. Who knew? Okay. So, let's get back. So we have to represent this expansion using sigma notation, all right? So another way to represent this exact same thing, okay, to say this exact same thing, but in sigma notation. The way it works is this. For sigma notation, you need, you guessed it, a sigma, okay? R, remember R are the terms, and what did we say about R? We said R started at 0, and it goes up to 17, okay? And inside, what do we need inside? Well, we need our binomial coefficient, so n, which is 17, and r has to be a counter. And then here, we have the first term times n minus r, the second term, not times to the power of, sorry, the second term, r. Okay, so do you see how, like, this is exactly the binomial theorem? What did the binomial theorem say? We had c n r, and then a n minus r, b to the r. So do you see how it's the same thing? That replaces that. A to the n minus r, b to the r. Okay, and there you have it, guys. In sigma notation, it looks like that. Okay, so thank you very much for tuning in. I'll see you guys in class on Tuesday. And for Tuesday, I would like you to please complete this homework. Thanks again. Have a great weekend, everybody.